Wait a second. Okay. That in Zeptoscript, you can do a lot of things in a much more fluid fashion than you can in Forth. Like, for instance, here is a bunch of code for taking a string. And then for every part of the string where you have a period, it inserts a 1 or a 0 for all the possible permutations of ones and zeros. Like, for instance, first thing, let's split a string in with a delimiter, just as an example. Foo, bar, baz, quux, and we are going to do split it with this. And then this will give us an array of strings, basically. Well, an array of byte arrays. There's no difference in Zeptoscript. And I'm gonna go and iterate over it. And the string, it broke it up into parts. Then I iterated it over and I added a index and I output the index and then the string. And then for the same example, for the example with where we're going to do all the possible permutations, we do what did I do wrong? Oh, duh. Okay. Here, what we did was we first split this on the periods, as we see here. Then we go in here we go and make a template string there where we broke up the string into first we broke it up. Then we took the array of strings and we made a new array with gaps in between. And then here we inserted ones and zeros for each possible permutation of a binary number. And then here we joined each array of strings, which we mapped over. And then we outputted it here where we typed each one out like this. And you might say, oh, this is just you can do this in Forth. But the thing about Forth is that Forth, it's hard to do things like play around with nested arrays of arrays, or in many cases, what we do here, like we construct arrays by making lists. Think like lists in Lisp, for instance. And we cons them in reverse order. And then when we're all done, we reverse the list and create an array out of it. The reason to use an array is that arrays are more efficient space-wise than lists are. And you can do all these kinds of things very fluidly. Or like, for instance, let's say we want to go in uh, have a list of numbers that we go in sort. We and here's our list. And then we go in, use we're going to use a sorting function. And then we're going to type the, oh, okay. See here, we created an array, we sorted it, and then we printed it out. And a lot of these things are trivial to do, whereas in Forth, they're not so trivial. Or let's say we want to go in associate each of these numbers with a string. So we're here creating an array of arrays. And each array in the array contains a number and a string. And I'm gonna, just for the sake of brevity, remove some of these. So here what we do is we sort these by we sort them by their numbers, and then when we're all done, we print them out. Oh, okay. It's My bad.
I like the error messages.
Yeah, that's something that this inherited uh, from Zeptoforth. That what I did was rather than oh, forget about that. That instead of using hard-coded numbers for error codes, which I do use in my compat module to make it a little more compatible with ANS4th, but in native Zeptoforth, it just uses execution tokens for exceptions. And I added some little nice things like when exceptions are the execution tokens are executed if the exceptions are not caught and are not re-raised, and then it prints it out in nice red colors. But anyways, here we can have these are actually 3 levels nested arrays where you have an outer array, then each pair inside is an array, and then these strings are well, byte arrays inside that. And it's really easy to work with this kind of stuff. Whereas in Forth, you have to plan all your memory usage exceedingly carefully. And if you don't, well, you'll have to redesign once you realize you can't do what you want to do. So that is this example of code. And then, well, I was on vacation recently, and I was reading the Pragmatic Programmer. Excellent book. If you haven't read it, you should read it, all of you. But one example that they had of concurrent programming in it was making a pina colada. And you could say, what's significant about concurrency and pina colada making? Well, uh, pina colada making is you don't have to do everything all at once. There's no reason why you, as in the example that is in the book, why you have to get your pink umbrellas at the very end rather than get everything that can be done without any dependencies first, and then the next dependencies down the line and all that until you finally get to the last things that you do. So let's make a pina colada. And here, the pina colada, in this example, we used actors, which you might be familiar with from Erlang or Elixir or something like that. But in this case, I created actors in Zeptoscript. And here I'm using the Zeptoscript multitasking module to, and the core part of the actor is all the actors share this is this. We create a map, which is like you might know as a hash table or a dictionary or anything of that sort. Which, well, in this case, it's implemented with a hash table, but we don't really care about the implementation. So we'll call it, except for that it requires a hash function and an equals function. But once we've created it, it doesn't really matter. And each actor, we create a channel for it, and then we fork. And when inside the new task, we pass in the channel, and otherwise we return the channel. And then when we're going in, each actor receives messages. And each message, there's a number of different messages. There's a couple messages used for tearing down everything when we're done. But the ones we care about are a pair of a source actor ID and a unique ID for the act of making a pina colada, just in case, let's say you have an order from a whole table full of people who all want pina coladas. So we take the message, which is a pair, and we dump it out onto the stack. We make local variables out of it, and we pass them into our check condition thing, which these conditions are here, which is an array of all the things that are necessary for a given step. So each actor has a map that maps an ID, a unique ID, with the current number of steps that are pending or have been completed, but we're not all done. And each map is a set. Again, we're using data structures in a very ideal fashion where we don't have to worry about, oh, how am I going to allocate my memory to make this happen? Which makes this so much easier than doing it in Forth. Of course, in Forth, you would probably say, hey, we'd use a bit array for our conditions and all that, but that doesn't make for very nice readable code. So we check the map for the ID. If it's not there, we create a new set, and then we insert the new actor ID from the source into the set. Then we update the set in the map just in case it's not already there. And then we check this nice little function here is called all. So what we do is we take our conditions and we iterate over them, and we go and check whether they're in our set. And a nice little bit of code here, which you'll see in a lot of Zeptoscript code, is this word bind. Because in Forth, an execution token is just a pointer to the start of the code in a word, nothing more. But in Zeptoscript, it supports, I sometimes call it closures, but that's not a really accurate name. A better name is partial application, which we take, in this case, the actors set, and we bind it to this word here, which checks whether something is in a set. And then so that every time that this is called, this is passed in as the first argument. And then we iterate over this, and we ensure that this always returns true. And if it does, then we know, hey, we've got all of our preconditions met. Like, for instance, when we want to be served a pina colada, we need to have got the pink umbrellas, gotten dishes, and we have to have opened the blender a second time. And then if that's true, then we print out our message to the user saying, hey, we've served the pina colada. And then in this case, in each of these steps, we go in and do something similar where we create a message for this actor and the unique ID for this pina colada. We make a message and we take our array of our actor map, and then we iterate over all the outputs, which in the case of serving a pina colada, we have only one output, which is our, hey, we're done now. We can tear down everything if we want to, or we could just make more pina coladas. And we make a message here, which we're creating a pair, which is a 2-element array, and we send it to the destination. And we iterate over all the outputs, which in this case, we'll have only one output. But let's say in the case of when we are first starting out making pina coladas, we have 5 outputs because we need to initialize all the things that can happen without any other preconditions besides the fact that we are starting making a pina colada. Or when we're opening the blender first time, that'll enable us to throw in 2 cups of ice, pour in the rum, and pour the mixer. And the big thing about all this is that implementing this is all very effortless in Zeptoscript, whereas I would have probably taken far much time implementing this if I had done it in Zeptoforth. Of course, Zeptoscript does have its limitations compared to Zeptoforth. For instance, Zeptoforth has preemptive multitasking, whereas Zeptoscript only has cooperative multitasking because of the reason that if you have 2 tasks that share the same heap that are preemptive multitasking, you have to handle the case where you see one task mid-operation acting on the heap while another task causes the GC to fire, and that makes things a whole lot messier, which of course some languages quote unquote solve that problem by using a global interpreter lock, such as infamously Python. But of course, a global interpreter lock adds a lot of unnecessary complexity and overhead. So instead, I just do not support preemptive multitasking within Zeptoscript. Mind you, you can still use preemptive multitasking, just not for Zeptoscript itself, because Zeptoscript is on top of Zeptoforth. It's essentially a big application that uses Zeptoforth other code can use preemptive multitasking at the same time, which might be useful because, let's say in the case of RP2040, you got 2 cores, and if Zeptoscript is running on 1 core, you got a whole core that you aren't making use of. So so this is just a nice example of what Zeptoscript can do. I could go on further, like for instance, I implemented a FAT32 driver for Zeptoscript, but I assume I don't have enough time to explain all that in detail. So before I call it a day, does anyone have any questions?
I do.
Go ahead.
You first.
Okay. Can you tell us more about your garbage collector?
My garbage collector is the Cheney's algorithm, which
Can you spell
Cheney's
that?
algorithm is a semi-space stop and copy algorithm. You might say, hey, we're wasting half our heap at a time because we're using a semi-space algorithm. But the reason why I chose Cheney's algorithm is rather than, let's say, mark and sweep type of algorithm is because it's a compacting algorithm, meaning that you never have to worry about heap fragmentation, except for when it comes to cache performance. But chips like the RP2040, you don't have to worry about cache performance in practice. So but the problem that when I read about, I never run into this problem personally because I don't really play around with MicroPython that much, is that people write programs like, let's say, a autonomous weather station in MicroPython, and they let it run for a few weeks, and then it fails and dies. And they wonder, why did my weather station fail? It was measuring the temperature and humidity just fine all this while, and then it died. Well, there's a reason. Heap fragmentation. That because MicroPython does not use a compacting garbage collection algorithm, if you're not very careful about how you manage your memory, it can run out of usable memory even though you haven't actually used your whole heap, which is bad. And I figured it was only having half of a heap at a time is a small price to pay for having reliable code where you're guaranteed to never fail due to heap fragmentation.
If you've got like one last question or wrap it up.
I have a quick question. What is Zeptoforth? Is Zeptoforth itself written in a machine language?
Zeptoforth is written in ARM thumb assembly and in Forth.
Okay. I'll make one other comment, and I can maybe comment later, but essentially what you do in splitting strings is a couple of words in cozy. The other thing is the memory management in cozy. I essentially followed Arthur Whitney's structure in K, so it's reference counted. Every list, every object created in cozy is reference counted. And when the reference count returns to 0, it's freed. and it just Arthur uses just a essentially a list of slots. He never moves anything. But in any case, we can talk about that elsewhere.
Well,
Right.
yeah. Well, the thing about reference counting is that if you use a reference count, you have to keep a count cell for each of your individual words, which
Yeah, well, yeah, to interject, one of the reasons why, actually, I had, when I was out there for one SV Fig, I actually had a conversation with, what's his name, Thompson, at the Bean scene, and talked about this issue. And I was wishing Arthur Whitney had been there, because one of the things, in terms of any arguments about it, you got to look at kx.com, because that's what Cozy is extremely structured on, and they essentially are one of the fastest large-scale database systems in the world. And one of the reasons why that overhead is so small is that generally when you allocate some memory segment, it's for an entire string. You're assign, and the other thing is that everything is a list of lists. You're working within a dictionary. So in any case, actually, Cozy surprises me how fast it is. And again, Arthur's is among the fastest. I mean, they arguably they advertise themselves as being the fastest large-scale database system in the world. So,
well,
Okay. Travis, wrap up in 30 seconds, and thank you so much for your talk. And no more questions or comments, please.
okay. The reason why I chose Cheney's algorithm is in part is that it is very simple and it is probably one of the it's not real-time friendly. So you don't use Zeptoscript if you need something where you need real-time performance. Zeptoforth is much better for that. But if you're talking about straight more amortized speed, is very fast because allocating memory is just advancing a pointer, nothing more. And furthermore, when the garbage collector runs, it only operates on the working set, nothing more. Unlike mark and sweep, where you have to iterate over the entire heap, with Cheney's algorithm, only the data that you're actually using is ever touched, which actually in practice speeds things up quite a bit, which I'd say the only disadvantage of Cheney's algorithm is the fact that you only get to use half your heap, but when faced with things like memory fragmentation and such, I think it's worth it.
All right. Thank you so much, Travis. John Peters, are you ready to go? He's still muted. Okay. I'm really grateful to the presenters. I'm sorry to be pulling the plug or getting out the hook for you folks, but I know it's not fourth day, but we need to fit in everybody. And Brad has gone through the trouble of producing an answer to the challenge, and it's the very end. So I want to be sure to have time for that. So John, you're on. Introduce yourself.
Can you stop sharing so that I can? Okay.